With this video, class 8, we are going to start the chapter or the topic energy. Though the topic is energy, let us start with something called work. Now, work is said to be done when a force acting on a body makes the body move. Get one thing very, very clearly. Whenever we say work is done, there has to be a force acting and there has to be some movement produced of the body. Therefore, when a force acting on a body makes the body move, we say work is done. Like for example, a girl passes a basketball to her friend, so the girl is applying a force to pass the ball and the ball moves some distance. So therefore, the girl is doing work in this case. Likewise, a boy is lifting a book up, so the boy is also doing work because in order to lift the book, the boy has to apply a force, and the very fact that we are saying he's lifting the book means there is some movement of the book. So therefore, the boy is also doing some work. A man climbing up a ladder. In order to climb a ladder, the man has to apply some force, and he's climbing up means there is some movement produced. Again, therefore, the man is doing work. A girl is squeezing a rubber ball. You have a rubber ball and you squeeze it. So in order to squeeze it, you apply a force. And the ball gets squeezed, meaning there is some movement of the ball produced. So therefore, there again, the girl is doing work. But in some cases, what happens is, there is force acting, but there is no movement of the body. So in that kind of a scenario, remember, the work done is zero. That is, no work is done. Like for example, your physics teacher is trying to push a wall. Now, will the wall move? Obviously not. Your physics teacher, I don't think, is a Superman. So therefore, your physics teacher will not be able to push the wall. So to say, the wall is not moving. So although your physics teacher is applying a force, but the wall is not moving, therefore your physics teacher is not doing any work. Remember that. So don't forget, for work to be done, there has to be a force acting and there has to be some movement of the body produced. Both of these two, that is the force acting and the movement produced, are necessary criteria for work to be done. So, how therefore is work measured? Work is measured by multiplying the force acting and the distance moved by the body in the direction of the force. Like for example, I have this coin. I apply a force and the coin is moving. So, here therefore work is being done. And how much is work done? Work done will be the force that I've applied with this pen multiplied by the distance that the coin has moved. Now, since work is something that can be measured, thereby it is a physical quantity, and we know that in order to measure any physical quantity, we need the help of a unit. Therefore, the unit of work is joule. This happens to be the SI unit. Now, what is joule? Joule is Newton multiplied by meter. Newton is the unit of force, don't forget. Meter is the unit of distance. And that is exactly what we are doing. The unit of force is Newton, and the unit of distance is meter. So Newton into meter is what is called a joule, remember. And joule is denoted by a capital J, and it is the SI unit of work. The other unit could be kilojoule, denoted by a small k, capital J. 1 kilojoule is equal to 1000 joules, because kilo means 1000, don't forget. So let us now see what are the factors affecting the amount of work done. Now, we've already discussed there are only two factors that affect the amount of work done. Number one is the magnitude of the force acting, and number two is the distance moved by the body. And you need to understand, more is the magnitude of the force, more will be the work done. Like again, take this coin, I apply a small force, it only moves a small distance. I apply a big force, it goes out of the frame. That is, more work is done, as you can see. The second one, distance moved by the body. More is the distance moved by the body, more is the work done. In this very example of the coin being displaced, you could see that in the first case, the coin only got displaced by a small amount, so small work is done. In the second case, the coin went out of the frame, it moved a bigger distance, so therefore, if it moves a bigger distance, if the body moves a bigger distance, then the work done will be more, of course. Let us talk about energy now. Energy is the capacity or the ability of a body to do work. Remember, capacity or ability to do work means the more energy I possess, I am more capable, or I am able to do more work. The lesser energy I have less ability to do work. So more work we do, more energy we need, and lesser work we do, lesser energy we need. In fact, what is true is work and energy are one and the same thing. They are always equal to each other. Since they are the same, therefore the unit of energy and work are also the same. The unit of energy therefore is joule, denoted again by a capital J, and it is the SI unit also that of energy, don't forget. And how do we define joule? 1 joule is the amount of work done when a force of 1 Newton acting on a body moves the body by a distance of 1 meter. So 1 joule is 1 Newton into 1 meter. So let us now take a look at the different forms of energy. You've done this in your junior classes also, but still let us give it a recap. So the first is solar energy, the mother of all sources of energy. Solar energy we get from the sun, of course. Heat energy we get from anything that has a higher temperature. Light energy we get from anything that glows or lights up, like a bulb, could be a firefly, the sun itself. Sound energy we get from anything that vibrates. Electrical energy we get from generators. Chemical energy, we have it inside batteries. Nuclear energy we get inside the nucleus of atoms. Mechanical energy is possessed due to the state of rest or motion of a body. That is, anything which is at rest possesses mechanical energy. Also, anything that is running or moving also possesses mechanical energy. Now do remember, one form of energy can always be converted to any other form. So therefore, let us look at a few examples of energy transformation. Inside an electric generator, what happens is, it has its machinery parts. Some of those machinery parts, it starts rotating, and that rotation of the machine parts of the electrical generator is what produces electrical energy. Therefore, in an electric generator, mechanical energy is getting converted to electrical energy. In a fan, what is happening in a fan? Electrical energy is getting converted to mechanical energy. In a heater, what happens? Again, electrical energy gets converted to heat energy. In a loudspeaker, electrical energy that runs through the wires reaches the speaker and a loud sound is heard. So therefore, in a loudspeaker, electrical energy is getting converted to sound energy. Now, in a microphone, what happens is someone speaks and produces sound energy, and microphone converts that sound energy to electrical energy, which runs through the wires and eventually reaches the loudspeaker. So remember, in a microphone, sound energy is getting converted to electrical energy. Now you must have studied about photosynthesis in your biology. It is the process by which plants make their food. So what happens in photosynthesis? The plants, they use light energy they get from the sun, and that light energy is used to make their food, that is to generate chemical energy. In an electrical bulb, any kind of a bulb, whatever kind of a bulb it be, what is happening? Electrical energy is getting converted to light energy, because bulb gives us light, and we use electrical energy to get that. Now in a solar cell, what happens? Light energy is getting converted to electrical energy. Now thank God, in Darjeeling all of us have seen a steam engine. What happens in a steam engine? Heat energy gets converted to mechanical energy. Steam engine uses a lot of coal. That coal is burnt and it boils water. So the heat energy of that water is used up to move the steam engine. Therefore, heat energy is getting converted to mechanical energy. Now when we are rubbing the palm of our hands, what happens? When we rub the palm of our hands, we start feeling warm. So what is happening there? Mechanical energy is getting converted to heat energy.